afternoon, everyone. I hope everybody can hear me at the back. So, picking up on the theme that Cristiano concluded with, connect more, reach more, create more. Well, it's very simple to take that to the next stage and conclude that great products come from the integration of great technology in an expert system context. And one of the things we've spent many hundreds of man-years doing and many billions of dollars spending is being able to regard our technology portfolio as world-class. If you look at the elements of technology we have to bring together, they span all the way from the CPU environment into graphics, very complex power management subsystems, the complete panorama of multimedia technologies that we have to have in a phone, going from video and audio and image capture capabilities, ubiquitous connectivity, whether it be modem-based, whether it be Wi-Fi-based, the ability to store and transfer large amounts of data around a system, and appropriate memory technologies and structures to be able to do that with, the enablement of a multitude of software platforms that allow our OEMs to scale across multiple different operating systems, integrating complex RF technologies to be able to provide economies of scale when an OEM is looking to play on a global platform. For example, today we are facing somewhere in the region of 50 different bands of LTE that we need to support, and with the advent of carrier aggregation not too far off, the RF picture becomes even more complex. Position location is a fundamental technology that now needs to be embedded in every handset that is shipped, and as I've said, ubiquitous connectivity through wireless WAN is now something that I think really is looked upon as essentially a hallmark of what differentiates a really great handset from something that's mediocre. And all of these technologies required to be mastered in a world-class context. It's not good enough just to integrate. You have to integrate the best. And another thing to really understand is that the real power of all of these IP technologies comes to the surface when they're integrated in a manner where the data transfer that occurs between each of these islands of IP is optimized in a manner where the system is able to fully exploit the capabilities of the core. As we'll show you later, just having great IP put together in an immature way doesn't necessarily lead to a compelling user experience. And I think we'll show you some data that shows how much care and attention we pay to the systems engineering of our products in order to be able to make sure that all of the great IP we put together is actually able to deliver an experience that is much greater than the sum of its parts. So as I said, what we bring to the table is not only the mastery of the individual IP cores, it's the integration into a single piece of silicon that gives an uncompromising user experience. Now, specifically, for example, in the modem technology area, I think a lot of us are congratulating many European operators on the advent of LTE in Europe. Well, a truth that may not be that well known to everybody in Europe is that Qualcomm is actually now delivering its third generation of LTE technology. We were the world's first company to deliver multi-mode LTE way back in 2010. And we're now entering the third generation of our LTE modem technologies, and we support 7 different air interface modes. They're all written up on the slide behind me, but suffice to say that with our third generation of modem technology, we have provided global ubiquity in terms of wireless WAN connectivity. There is no part of the globe, no RF band that currently supports LTE that Qualcomm does not support. We will now move forward with modem technology that supports TD-SCDMA as well as TD-LTE, and we're able to support that in a multi-mode context to the degree that we can support 2G, 3G, and 4G technologies ubiquitously on a global scale. So again, one of the things we've really tried to do is to make sure that we have not only mastered the technology from an IP point of view, but reduced it to an implementation where it allows an OEM to really invest in the scale of global production that is necessary now to be able to really meet the diverse LTE requirements going forward as 4G ends up proliferating multiple bands in both an FDD context and a TDD context. Now, going back to some of the attributes that I think pay testament to the systems engineering expertise that we have been able to apply to our roadmap in Qualcomm. One of the things that's very, very clear is that just having great IP, as I've said before, doesn't lead to a great product. For example, if you can see the numbers on the slide in front of you here, what we're looking at, ladies and gentlemen, are data derived from a dual CPU architecture, the S4 8960 class of product, a dual CPU architecture in comparison to benchmarks that have been achieved by competitor quad-core architectures. So essentially you have, in the Qualcomm argument, an architecture that requires 2 CPUs. And we're able to generate a performance and user experience that way surpasses what others have been able to achieve with the utilization of 4 cores. Now, as you can see here, performance can be measured in multiple dimensions. Here we've looked at multimedia and gaming, web browsing, and application performance in terms of initiation and overall startup times for applications. And as you can see, what is evident in this slide is that not only does great IP need to be available, but it needs to be integrated in a system-aware context. And that's what we've done at Qualcomm. We've been able to really engineer the best of our IP and put it together in a package that has really been able to optimize the data transfer that has to happen between the various cores in our MSMs to really unleash the performance that the silicon is innately going to be able to provide. And I think what we are really looking at is how we continue to perfect optimum performance, irrespective of metrics of technology that one could argue. Quad cores, 6 cores, we talked about quad-core graphics cores as well. They are only relevant, those numbers are only relevant in the user experience we seek to provide to our end users. And again, moving on to our own quad-core implementations, as you can see here, as we normalize the benchmarking conditions between our quad-core and our competitor quad-core products, early data already shows a dramatic benefit that's been able to be derived from the Qualcomm architectures. Again, it not only speaks to the supremacy of our IP, it speaks to the supremacy of our systems integration. And this is even more important as you go forward in looking at the end user experience. All of the benchmarks we've talked about are relevant in the context of how they are precursors for how a product will behave in the hands of an end user. Richer and more powerful applications. The application startup times are in the flash of an eye. The frames per second basically make the videos and the application buttery smooth. Stunning multimedia and gaming experiences. Image capture that basically makes it look as though you're reliving the moment in exact detail. Really, really fast web browsing, where essentially the speed of your web page is as fast as the way you can move your finger on the screen or select a page, and to provide a high performance battery life, where essentially once you pocket your phone in the beginning of the morning, you really don't have to worry about putting it back into the charger until you get home at night. It lasts a full day and more. All of that comes from great IP integrated in a very, very expert systems-aware context. And then again, another challenge we're going to face as we go into the advent of multi-core technology. The biggest challenge we face, I believe, in the mobile design space going forward is how you're able to constrain the power of 4 CPUs running at 2 gigahertz plus, quad-core graphics cores running at 600 megahertz plus, Cat4 LTE transferring 150 megabits of data per second. Put all of those in either a semi-simultaneous or an aggregate simultaneous context. You have a very, very, very complex thermal envelope to manage. Most PAs are probably going to be in the region of 50 to 60% efficient. Most silicon is going to have an efficiency in that region as well. So if you look at the amount of power that is going to be generated by the subsystem that you power a phone with, and how much will essentially be dissipated in heat because of inherent silicon inefficiencies. One of the challenges we have is how we manage the thermal envelope, and we at Qualcomm have put a tremendous amount of effort of being able to develop very complex thermodynamic management executives which can keep all of that power in balance and in great harness. And as I think you'll see both in the slide in front of you and a video coming up, it's very, very easy to get into a situation where you get into a user scenario where, although the great power you have under the hood of your chipsets is great, if you can't harness it in a manner that leads to a profile that is thermally balanced, you can get into a lot of trouble. And I'm going to go to a video which I think really speaks volumes as to what that really means in an end-user context.
Thermal efficiency has become very important because from an end user's perspective, the phone or the tablet that a user is using gets so hot at times that it becomes annoying. We have 3 devices, a Qualcomm-based phone and 2 competitor-based devices. The thermal camera shows the thermal footprint that the 3 phones leave when running a CPU-intensive test. One way to show the results is via a heat map through a thermal camera. What we are trying to compare is thermal efficiency when the CPU is delivering peak performance. As you can see, the phone based on Qualcomm's chipset is much more thermally efficient compared to the competition. Another way of showing results is by melting butter. Yeah, melting butter. Butter melts at 35 degrees Celsius. As you can see, the phone based on Qualcomm's chipset is much more thermally efficient compared to the competition. One of the phones that is heating up the most is heating up to 55 degrees Celsius. That's hot, that's really hot. Qualcomm Snapdragon S4 is the coolest kid on the block, and we mean it literally.
So somewhat of a flippant video, but conveying a very, very important message. One is all of that power that's going to melt all of that butter is power that you are deprived of in terms of being able to get through a day of heavy usage of a smartphone. And secondly, what it also exemplifies is being able to allow an end user to have his phone always operate at a point of peak performance without getting into issues of thermal control, which means various elements of the capability of the phone need to be throttled back. Clearly, the only way you're going to manage a situation where you have a problem of escalating thermal balance within a phone is to essentially shut down all of the elements in the phone that are actually consuming energy and dissipating half of that due to inefficiencies in its architecture. And therefore, what we've really been able to do is really create a balance between power and thermodynamic balance that allows us to maximize user experience and maximize battery life. And speaking of battery life, one of the things that's become more and more standard in the way attributes such as power is measured is in what we call days of use modeling or scenario modeling, whereas instead of just talking about individual attributes, about hours of video playback time or hours of talk time, really the metrics that are much more fundamental and relevant now are what we call scenario or usage-based modeling in terms of power. And some statistics that are worth sharing with you, for example, is a couple of scenarios we've modeled, which are very much representative of the kind of user groups that really put smartphones through their paces. Scenario 1 involves a mixed usage mode of web browsing, streaming TV to your phone, as well as listening to music. And in like-for-like conditions, the S4 level of processor was able to achieve almost 2 hours more than an equivalently spec'd part. And in the second scenario here, where it was a mixture of video chat, web browsing, and taking pictures, we achieved more than 1.5 hours more of extra battery life. And as I say, at the end of the day, one never really wants to feel a sense of apprehension in whether your typical usage model will ever be governed by your ability to be near a power point and charge your phone. I think what we've really tried to do is create architectures that allow a vibrant and fully unrestrained usage of a phone in many, many different usage scenarios, independent of whether you're a youth, surfing the web, listening to music, browsing the web, or whether you're a professional whose main goal is essentially making sure they're up to email, synchronicity, making lots of phone calls, and making sure that essential web material is available to you at your fingertips. So again, a tremendous amount of effort in terms of system efficiency, battery management, and thermal management. So what has all of that technology mastery and systems expertise really gained us from Testament of Success? Well, I think the slide in front of you really, in our minds, is the truest report card that can exist. And what we have today on the Snapdragon processor family is over 50 manufacturers making use of Snapdragon technology from Qualcomm. More than 400 devices announced and launched already. 400 others are already in development, and over 30 tablets in design. And amongst all of those statistics, about 175 use our latest generation of AP processor, the S4. So clearly, I think a lot of OEMs and a lot of end users have been able to discern for themselves, maybe in less numeric form and less technical terms, the benefits I've shared with you today. But that really is what we're doing to drive mobile communications forward, innovating across the panorama of technologies that you now have reposited in a cell phone, and delivering that in a balanced and well-harnessed manner that allows everybody to get the user experience they want, with a battery life they want, and in an uncompromising fashion. And with that, I think I hand back to Enrico to introduce our next speaker.